All right, grade 11. So this is just a summary of the sine, cosine, and area rules, the formulas, and when you would use them. So that's in the notes that were posted on the Google Classroom, but it's just a nice little summary of that. So in order to see your checklist of when you'd want to use this. All right, so let's go on to some of the more difficult examples. So we are going to work with situations where you have your angle of depression, angle of elevation. We're going to use things like angles of a triangle, parallel lines. So we are going to mix the work quite a bit, but to a point it really does stay quite easy. So when we're working with mixed examples, they're just things that you need to think about. So one of them being angles in a triangle, your basic geometry, angles of elevation and depression. Okay, remember it always comes from a horizontal. So depression is down from a horizontal and elevation is up from a horizontal. All right, and then don't forget your normal trig is still there, your opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. Use that in the right angle triangles. You can use your sine and cosine rules, but why do that when you have the easier, more straightforward trig to work with only in right angle triangles? Okay, start with the triangles that have given you lengths. More specifically as well, start with where you have the most information and work your way to where you need to be. Then, very importantly, you need to find a link side. And I'll show you what I mean by that. It's when you have multiple triangles, it's what side will be the link to be able to jump between any two triangles. And then you use the link side to move from one triangle to another to find lengths or angles where you need them. All right, so let's have a look at the first example here. All right, so in this sketch, you can just see what's on the diagram here. It is a quadrilateral. It doesn't specify what type of quadrilateral. They've given you AB is 8 units. So you've got some information. You've got AD is 12 units. You've got angle A is 110 degrees. And then in the other triangle, you've got B1. You've got angle C given to you there. And then they've asked you to calculate the length of CD. So we're first looking for that side. So in order to work out the length of a non-right angled triangle, you need to think, okay, what do I have? I've got the angle opposite, and I've got this angle. I could work out D1 because I have two angles of the green triangle. Let's make this green. So then I could work out the third using angles of a triangle. But in order to work out a side, I need another side at least. So let's try to see if we can get BD. Now, if you notice, BD is the overlap between the bottom triangle and the top triangle. So that's what we call our link side. So if we can work out BD using the majority of the information which is at the top, then we can use BD in the bottom triangle to find DC. All right, so go to the triangle that has the most information, especially the ones with the side lengths. So how would I work out BD? Well, let's see what I've got. I've got side, included angle side. I've got the angle and I've got the one across from it. I don't have a complete pair of side to angle, so I've got to use the cosine rule. So BD squared. All right, so just jumping to the cosine rule, we get BD to be 16,54 units. All right, then they want the side DC. So now we have some information here. Get rid of that. So now we know that this is 16,54. We've got the side opposite, so here's the angle opposite, sorry. So we have a complete pair. We've got an angle and we need this side, so we can use the sine rule. So we have DC over sine 35 is equal to 16,54 over sine 95. Sorry, that's a bit messy. All right, so we're going to get DC by itself by bringing that sine 35 across. All over sine 95, and we're going to get DC to be 9,52 units. All right, so then they're asking you for the area of the whole shape ABCD. Now it's made up of two triangles, and within those two triangles we've got some information. So let's just put this back in: 16,54, 9,52. Now to work out the area of non-right angle triangles, you need side included angle side, and then in the other triangle we have, here are two sides, but we don't have their included angle. But as we discussed, we can work it out using angles of a triangle. All right, and then once we've got D1 with using angles of a triangle, we can work it out to be 50 degrees, and then we can use side included angle side, and then we have half of our two sides times sine of the included angle. All right, and that gets us to 60,31 square units. And then we need to work out the other triangle's area, but that's easy because we already have side included angle side. So the area of triangle ABD is equal to half of 8 times 12 sine of the included angle. And that gets us to 45,11 units squared. And then we just need to bring it together. So the area of the whole shape is going to be 60,31 plus 45,11, and that's going to get us to 105,42 square units. All right, so you can now get on with exercise 4 and have a look at some of those. It's also ones with numerical problems, with a link side. And don't be afraid to cut a shape in half if you need to. If it's a rectangle or a trapezium, find triangles. The whole idea here is to talk about triangles. Okay, so you are working on A, C, E, and F from exercise 4 from your textbook. In the next video, I will cover the variable types, which are the slightly more difficult ones.